Article 220.22 addresses the sizing of neutral conductors. It is important to understand its application, especially in multifamily dwelling units served by a 120/208 volt single-phase system. The question at hand is whether this article prohibits reducing the neutral conductor size. The answer is no. Article 220.22 does not prohibit reducing the neutral conductor size under specific conditions. To elaborate on this, we must first understand the fundamentals of neutral conductor sizing. In a balanced 3-wire, single-phase circuit, the neutral conductor carries only the imbalance between the two hot legs. This is because the current returning on one hot leg is ideally equal and opposite to the current returning on the other hot leg, resulting in a net current of zero in the neutral. However, in real-world scenarios, perfect balance is rarely achieved. Loads are seldom perfectly distributed between the two hot legs, leading to some current flowing in the neutral conductor. The National Electrical Code, or NEC, provides guidelines for calculating the neutral load to ensure the neutral conductor is adequately sized to handle the expected imbalance. Article 220 specifically addresses branch circuit, feeder, and service calculations. Within Article 220, different sections deal with specific load types and calculation methods. For dwelling units, the NEC provides demand factors that allow for reductions in the calculated load based on the understanding that not all loads will operate at their maximum simultaneously. These demand factors recognize the diversity of electrical usage in residential settings. Article 220.22, which is relevant to this discussion, addresses the neutral conductor load. It permits the reduction of the neutral conductor size under certain conditions. This reduction is based on the understanding that the neutral conductor in a dwelling unit typically carries less current than the ungrounded conductors, particularly in systems with significant nonlinear loads. Nonlinear loads, such as electronic devices, computers, and LED lighting, generate harmonic currents. These harmonic currents, specifically the third harmonic and its multiples, are additive in the neutral conductor in a three-phase system. This means that instead of cancelling out, the third harmonic currents from each phase add together in the neutral. This can result in a neutral current that is significantly higher than the current in any of the phase conductors. However, in a single-phase, 3-wire system, the effects of harmonic current on the neutral are different. The third harmonic currents generated by nonlinear loads on each of the hot legs will tend to cancel each other out in the neutral. This is because the two hot legs are 180 degrees out of phase with each other. Therefore, the third harmonic currents generated on each leg will also be 180 degrees out of phase, leading to cancellation in the neutral. The NEC recognizes this phenomenon and allows for a reduction in the neutral conductor size in dwelling units, even with the presence of nonlinear loads, provided certain conditions are met. Firstly, the calculated neutral load must be determined in accordance with Article 220. This involves calculating the total connected load on the circuit and applying any applicable demand factors. Secondly, the reduction in neutral conductor size is typically limited to the portion of the load that consists of electric ranges, ovens, clothes dryers, and similar appliances. These appliances are considered to be less likely to generate significant harmonic currents. Thirdly, the neutral conductor must still be sized to carry the maximum possible unbalanced load. This is typically calculated as the largest phase load minus the sum of the other phase loads. The NEC requires that the neutral conductor be sized no smaller than the calculated unbalanced load. It's crucial to understand that the permission to reduce the neutral conductor size is not a blanket allowance. It is contingent upon meeting the specific conditions outlined in the NEC. These conditions are designed to ensure that the neutral conductor is always adequately sized to carry the expected current without overheating or creating a safety hazard. It's also important to consider the potential for future changes in the electrical load. If the dwelling unit is likely to experience an increase in nonlinear loads, it may be prudent to avoid reducing the neutral conductor size to provide additional capacity for harmonic currents. Furthermore, local codes and regulations may impose additional restrictions or requirements on neutral conductor sizing. It is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. In summary, Article 220.22 does not prohibit the reduction of the neutral conductor size in a multifamily dwelling unit served by a 120/208-volt single-phase service. However, this reduction is subject to specific conditions outlined in the NEC, including the calculation of the neutral load, limitations on the types of loads that can be considered for a reduction, and the requirement to size the neutral conductor to carry the maximum possible unbalanced load. Careful consideration must be given to the potential for future load changes and compliance with local codes and regulations. Understanding the principles behind neutral conductor sizing and the requirements of the NEC is essential for ensuring the safety and reliability of electrical systems in multifamily dwelling units.